welcome to Code, a journey to become a blockchain developer from nothing. Today we are going to talk about Solidity. And personally, I believe the official documentation is the best resource to learn Solidity from a very practical way. Along the way, if you feel my speak is too slow, you can turn into X or 1.5 speed. Let's get started. So if you check this documentation, the reason I believe is because if you check out the resource online, you will realize a lot of page or authors that actually reference from this file in a different way. So to get the best exposed, if you coming from nothing like me, I think this document is the best way you to learning from and to get started with this language. And today we are going to go through this one, a simple sample smart contract, and maybe later on we go through other documentations as well. So this one is a very simple smart contract, and the best way using this documentation is here. You can actually open from a remix. So what I'm going to do is right click and I would like to open in a new tab. And for those people you don't know what the remix is, this is actually a very convenient application running on every browser. So you don't have to set out any VS Code or coding environment. You can directly working on your browser from Apple or Mac. So at the first step, you can see on this IDE, here we get the tab. So this is the home tab, and this is the file we just input from here when you click this arrow. So see, it directly just copy paste all the necessary code here. You don't have to type again. This is very good for people who are not familiar with coding or even don't have any experience in coding. And then from your left hand side, you get this logo. So once you click, you go back to the home page, and then you get the file panel, file page, and this is a compiler page, and this is a deployment page. The reason why we have compiler is because Solidity is a compiling language. So it's not something like you code and you execute and you print out the result. The language itself need to compile with a certain way and then deliver the result. So this is why we need to have a compiler. And then after we compiling the code, we can deploy on the blockchain. The best way and the benefits using Remix is actually it gives you everything from one page. So you don't have to compile with another tool, with another ID. Actually, everything's here. And the best of all is when you deploy, it actually give you a fake network environment. Meaning, just like you're selling a car, you're compiling that means you actually assemble the car with different parts. And once you make a good car, you don't have to worry about where to sell. When you deploy like you're selling a car, here is actually the place help you just to deploy on a fake network. So in blockchain, once you finish your contract, which is here, you have to deploy on the blockchain or network, and this is where you can do that straight away. Okay, let's get started. So let's do this one by one. The first one here, you declare your copyright or your license. You can type whatever you like, but there's some option that's popular, which are this one or the MIT or other one. You can just Google that. And next slide is the compiling version. The compiling version tells the compiler what version I would like you to compile. Why is important? Because when the compiling upgrade, a certain weight of code is changed. For example, we don't have the safe map, meaning when you code in Solidity, 1 plus 1 or 1 minus 1, you have special syntax. That's in the previous old version of Solidity, but in the latest version that is integrated into the compiling environment. So once the Solidity upgrade, the compiling is upgrade as well. So that's why you have to specify what compiling you're doing, because that is matter when you write your code. So you're using a certain way to write your code, you need to follow a certain compiling number of version. But in a broad way to say, it gives you quite a big range of compiling, so it is good. Or normally you can just specify something like compiling a certain version 0.8.4 something. Okay, followed by a contract. This contract is a main story. So in this contract, first of all, this is the name of the contract. We call it simple storage. So this contract or this program is called simple storage. And then we have a variable here. So variable is called storage data, and is followed by a type of this storage, which is unregistered number. And we got two functions. The first function is called set. So we want to have the function, and later on we can input this function after we deploy it. And the second function is the get function. So once we deploy it, we assign a value. We want to extract the value from the blockchain. So let's go deeper to each function. So in this set function, the type of the variable we want to assign is also a number, and then followed by a keyword called public. So because blockchain is a chain or a network that everyone share the information, everyone process the same version of information. So the quantity you put into the program or contract is very selective. So you have to tell the compiler whether I want to put public, private, that matter to the overall cost when you deploy it. So in reality, when you deploy a contract, that actually costs you real money, which is most likely the Ethereum. In this coding environment, we use the fake money, so it doesn't really matter, but in reality it matters. Since it matters, you have to tell the environment whether I want to put this code publicly or privately. That matter to the cost of your deployment. And in here we call it public, it meaning once you deploy it, anyone can publicly interact with your contract. Okay, we will dig more in the future about all these details, which is the feasibility of function. So let's just look at again about this contract. So firstly, we declare a variable called store data, and in this function we actually assign a real number of real value, which is a number, to this variable. So initially there's nothing in it, and this function just allow people to give this variable a number, a value, and then after that we can get directly from this value. Also, you can see here the public is the same, so publicly people can interact with this function, and the view basically telling the environment, say this function, nothing need to be changed. We're just viewing this function. We just extract the function. So technically speaking, this function costs basically nothing when people interact with this. So we specify, tell the compiler, tell the deployment environment, when this function is interact, nothing need to be paid. So the people who use this function, they doesn't need to pay any Ethereum because we just check the data. So we put this keyword here, view. Alright, so suppose you understand everything, we can start to compile this code. So basically the the easy way is using the control. If you're using Windows, you can control save. Using Mac, you can use command S. So control S or command S. Or you can choose this tab and select the version you like. So normally you can choose the latest, or you can do whatever you like, but make sure that match the range where you declare here. Then I choose the second latest one, maybe you can choose the stable version one. It doesn't really matter too much. It matters from 0.8, from 0.7 to 0.8 maybe. So you can compile, click compile. So within a second, you finish your compiling result. So you get a contract here, simple storage, which is this one. Your name of the contract, and you can go to the third tab. So here is the environment. This is what I'm talking about, the blockchain network. So you got a lot of options here. Today we only choose this one, JavaScript V and London. I will talk about more in the future about REST. This one gives you a fake network. So basically Ethereum network or blockchain you can deploy on. So it's just a name for that. And then you don't have to worry about the REST one. This is only the one you need to be aware of, what blockchain you want to deploy it. And the second one, the contract, is the wallet address. So you must have an address to deploy it on the network. So this address is to use to sign this contract. So for example, you distribute your assemble card to a distributor. So the one who purchased this card must have the name on that, right? So you must have your wallet address. And this one is also the fake one. So it gives you 20 address. You can use whatever you like. Normally people use the first one, and it actually also give you 100 fake ether to deploy. So remember, deploy anything on the blockchain, it costs money, which is the asset. In Ethereum is ether. Alright, so this is the first one. This is the second one. You have to understand. You can skip others. And maybe the third one is what contract you want to deploy. So in reality, you might have a lot of tabs. So once you compile, make sure in your deployment, you select the right contract. Believe me or not, this is the most common mistake that people made. So they thought they deploy the right one, but end up they get a lot of error message or something. They just confused simply because they just haven't choose the right contract. So make sure you set the one, and then you can click deployed. That's it. So within a second, you get the result. Once you see this green little arrow, that means the successful operation or transaction in blockchain terminology. So here you can see a new contract deployed. It's not obvious, but you can click this little peel, then you can see you get two little buttons here. So the orange one means everything need to pass a transaction process, meaning when you want to assign a value, which is this function, set this function. So this name set is this name. Okay, this is not a generic name. This is actually the name you type yourself. So if you type set1 in the future, you compile and deploy again, this will be changed to set1. Okay, so the orange, back to this one. Orange is actually when you do something, you need to send a transaction in order to get the action. However, this one, the dark green one or blue-green one, you don't have because you just read the data from blockchain. So it doesn't need to pass the validation of transaction. We will dig this more in the future videos when we talk about how exactly the blockchain works. Okay, so now if you click this little peel again, they're pretty much the same. It just give you more information about this set function. So here we got unregistered integer 256, meaning you can type whatever the number, basically whatever the number you like to this contract. So let's type, I don't know, 999, and you click transact, and see you get another successful message when you ever again to see this green tick, meaning the transaction is or deployment is legit, is successful. Now if you get function, so you don't see that because we don't go through a transaction, we just read a function, but this is also successful, which is 999. We can redeploy the contract again, and for that we can click this first, see it should be nothing, but this time we try another one. So let's try 333, and let's click transact, and then we've clicked the get again, tell us that's 333. Okay, so what's going on behind the scene is once we assign the number here 999 of 3333, is store that value to here, store data, and back to this one. So this data will always keep the version that we assign in the blockchain. And once we retrieve the data, we click this get, it will call this value and back to our panel. So we will see this, the one of the latest value we type. Now notice here, before we finish, we just want to try, if we type a string, which is for example, if we type something instead of a number, we call whoa, and we click transact, it actually tells us an error, so invalid string. So what it says actually, in your contract, you only allow a number to be input. So if we want to assign a number value, it tells you an error because your contract only allowed a number. So the way we solve it is we have to rewrite our contract. So let's do this. In order to do this, I think the best way is just to remove this deploy contract. So let's click this rubbish bin here, because we are going to rewrite again and compile and deploy again. So in order to allow us to assign a string or text, we have to change our input function type as string, string, and also when we extract this, we expect to result and string as well. And of course, see here, you assign this value into x, and x becomes stored data, so your stored data must be string as well. Okay, so if you want to compile this on Mac, you press Command S, then you get some arrow here, and if you hover on this arrow, you can see it says must be memory or code data. Okay, it simply tells us this is sort of correct type we want to do, but you have to also tell some extra information to the compiler, to the deploying environment, how large the storage you are declaring. So we want something is within this function. Once this function finish, we no longer need this x value to be stored in the blockchain. So we use a keyword called memory, and we also use this keyword memory as well. So memory meaning once you finish this function, this x you can dismiss. So you don't have to memorize this x, because what we are doing here, we want to set a value for stored data is we use a variable here, and once this variable assigned to this one, we can dismiss x. So you don't need to cause any memory on that. So that's why we call memory here. So tell the Solidity about this function, you can just have a flash declaration for a certain variable. Once you finish this function, you can dismiss. Okay, so once you assign those two keyword memory, you can Command S. Those arrows should be disappeared, and you get a green tick here, meaning you're compiling successful. You can click again, but basically you're saying, okay, right. So once you finish your compiling process, you can go to the deployment. We do the send network using a send account, and we didn't change the contract name, so you can basically deploy it again. And if you watch closely, I didn't tell you to do so, but if you watch closely, your deploy contract address changed. Okay, now here, let's do again to assign the value. Oh, sorry. So before that, let's just check this get function. It's nothing. That's correct, because once we deployed, after we deploy, we don't actually assign any values. So let's do row. We call it transact successful, and then we click get. That's the one. And we can try another one. Maybe we just try, I don't know, welcome. We get welcome. All right, that's it. It's a bit long for those who have experience on Solidity, but I believe if you are zero knowledge about Solidity or any coding experience which you don't have, hopefully you get something from this. I will see you next time for other blockchain tutorial. See you then. Bye bye.